Hello, students. Today we are going to study a very important chapter in physics, gravitation. Gravitation is the force of attraction that exists between any two masses in the universe. I repeat, any two masses. It is one of the four fundamental forces of nature.
Sir, may I ask a question?
Yes, please ask.
Is this the same force that keeps the moon revolving around the Earth?
Very good question. Yes, gravitation is the force responsible for keeping celestial bodies like the moon, Earth, and other planets in orbit. It governs the motion of all objects in the universe. Newton proposed that every particle attracts every other particle in the universe, with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The formula is capital F is equal to capital G multiplied by m1 multiplied by m2 divided by r square. I repeat, F equals G into m1 into m2 divided by r square, where capital F is the gravitational force, m1 and m2 are the masses of the two objects, small r is the distance between their centers, capital G is the universal gravitational constant. The value of capital G is 6.674 into 10 raised to the power minus 11 Newton meter square per kilogram square. The gravitational field produced by a mass capital M at a point is defined as the gravitational force experienced by a unit mass placed at that point. The formula is small g is equal to capital G into capital M divided by r square. Now, gravitational potential is the work done in bringing a unit mass from infinity to a point in the field. The formula is capital V is equal to minus capital G into capital M divided by small r.
Sir, may I ask a question?
Yes, go ahead.
Sir, why is the gravitational potential negative?
Excellent question. It is negative because we assume that potential energy is zero at infinity. So as we move closer to the mass, the potential becomes more negative, showing that work is required to separate the masses. On the surface of the Earth, acceleration due to gravity is given by the formula small g is equal to capital G multiplied by capital M divided by capital R square, where capital M is the mass of the Earth, capital R is the radius of the Earth. The value of small g is approximately 9.8 meter per second square. Variation in small g with altitude. G dash is equal to G into open bracket 1 minus 2h divided by capital R close bracket. With depth, G dash is equal to G into open bracket 1 minus d divided by capital R close bracket. With latitude, G dash is equal to G minus capital R into omega square into cosine square lambda. Mass is a scalar quantity. It is constant and measured in kilograms. Weight is the force exerted by gravity. It is given by the formula capital W is equal to m into g. This means weight varies with location while mass does not. A satellite revolves around a planet because the gravitational force provides the necessary centripetal force. Orbital velocity is given by the formula small v is equal to square root of capital G multiplied by capital M divided by capital R. The time period of revolution is capital T is equal to 2 pi into square root of capital R cube divided by capital G into capital M.
Sir, may I ask one doubt?
Yes, go ahead.
Sir, does the mass of the satellite affect its orbital velocity?
Good question. The orbital velocity depends only on the mass of the planet and the radius of the orbit, not on the mass of the satellite itself. Escape velocity is the minimum velocity required to escape the gravitational field of a planet. The formula is V sub E is equal to square root of 2 into capital G into capital M divided by capital R. For Earth, this escape velocity is approximately 11.2 kilometers per second. Molecules in the atmosphere have thermal velocities that are mostly less than the escape velocity of the Earth, hence they remain gravitationally bound to the planet and the atmosphere exists. Gravity on the Moon is approximately 1/6 of that on the Earth, so the formula becomes weight on Moon is equal to 1/6 multiplied by weight on Earth. When a body is in free fall, like inside a satellite, the apparent weight becomes zero. Though gravity still acts, the normal reaction becomes zero. This condition is called weightlessness. Gravitational potential energy is given by the formula capital U is equal to minus capital G into capital M divided by small r. It is negative because we assume zero potential energy at infinity. Total energy of a satellite in orbit is the sum of kinetic energy and potential energy. That is, capital E is equal to minus capital G into capital M divided by 2 capital R. This negative value indicates that the satellite is gravitationally bound to the planet. That's all for today, students. We have completed the full chapter of gravitation, covering definitions, formulas, variations, satellite motion, escape velocity, and energy. I'll see you in the next class. Jai Hind.